Climate Science Watch spoke with Lawrence Livermore National Lab's Dr. Benjamin Santer about the attribution of extreme weather events to global climate disruption. We first asked, what is the most appropriate way for reporters and scientists to make the distinction between climate and weather when discussing the attribution of specific weather events, such as heat waves, droughts, intense precipitation, to climate change?
Here at the lab, we do fingerprint research, so we've been trying to look at the complex causes of climate change and use essentially signal processing methods to try and figure out the relative contributions of things like the sun, volcanoes, human activities to observe climate change. And through that work, we've been able to say with some confidence that human activities have contributed to the increase in the temperature of the planet, the cooling of the stratosphere, the warming of the lower atmosphere, the rise in the height of the tropopause, the boundary between the lower atmosphere and the stratosphere. But much of this fingerprint work to date has really focused on changes in average conditions. Now, many people are not really interested in changes in average conditions, but want information about specific extreme events, like the 2003 heat wave in southern Europe, which affected tens of thousands of people. And folks asked after that event, is this due to human causes? Did human activities lead to this event? The same questions were asked after the 2005 Atlantic hurricane season, which brought us 3 Category 5 landfalling hurricanes, Katrina, Wilma, and Rita. Was there human causation in these events? That's a much trickier, much more difficult question to answer than have human activities led to some change in the average. But scientists are bringing methods to bear in order to answer this question. Is there human causality in specific extreme events? And the techniques that they've used have really been borrowed from medical sciences and from epidemiology, where folks look at something called fractional attributable risk. The risk that arises, for example, through some treatment or failure to give some drug or medication. Scientists in the medical arena try and quantify the risk that accrues to a patient through some treatment or lack of treatment. And folks have used the same sort of approach to try and look at how human activities change the likelihood of specific extreme events, like the 2003 European summer heat wave. It turns out that you can run climate models, computer models of the climate system, with human influences in them and without human influences in them. You can look at something like the European summer heat wave, and you can see in the climate model world how has the risk of getting extreme warming in southern Europe in summertime changed because of the addition of human influences in the climate model. And you can quantify the change in risk, the likelihood of getting that extreme event, through the inclusion of human factors. And that kind of approach is now being used for other things, for flooding in Europe in recent years. People are starting to use this sort of fractional attributable risk method to try and look at how human activities have changed the likelihood of individual extreme events. And that's important, and folks even in the legal community and in the reinsurance communities have gotten involved in this sort of stuff. Many people are interested in the issue of whether one can indeed assign legal culpability to individual governments or companies, and whether human activities have exceeded some threshold that would enable us to say, more than 50% of the risk of this type of event is due to human activities. So this is a relatively new arena, but as scientists, we know that when you change the average climate, you change the tails of the distributions. Changes in extreme events like the ones we've seen this year are expected behavior. They're not things that are a great surprise to us. And we expect to see more of the same, more heat waves, more intense downpours in the future as the average climate changes.
In the wake of the surge in extreme weather and climate-related events this past summer, do you think we have reached a turning point in public perception about the connection between extreme events and climate change? What do you think is the most important message for the public to take away from witnessing these events?
Well, I don't know whether people's perception is changing. I do think, again, that it's important to get across that this is expected behavior, that climate is the average of many, many weather events. And as you change the climate, as you change average conditions, you also change the weather events that make up climate. We expect to see, as we warm the planet, more heat waves. We expect to see more heavy downpours. A warmer atmosphere can hold more moisture, and there are good physical reasons behind some of the changes in extreme events that we see. The change, for example, in the number of frost days, changes in the number of warm nights. We see in many individual indices behaviors that are entirely consistent with the change in the average climate of the planet. Whether individuals in the public are actually making this connection, these changes that we see in the time at which lakes start thawing and changes in the number and intensity and duration of heat waves, this is no longer natural. I don't know whether we're there yet in the general population, but again, I think it's important to get across the notion that these are not surprises for us. This is expected behavior. When you warm up the planet, you experience that through changes in weather that makes up the climate.